Okay, so I've given out hints numerous times, but we're going to go back to shock loading. Shock loading, all right? And this should be your what? Your energy built up, your whatever it may be. But I want you to think about this: a hammer and a nail. What does a hammer and a nail have in common with this building failure? A hammer and a nail, and I'll tell you an M. What does it have in common with M? This is M. I'm giving you, you can pause the video anytime you want and try to see if you can figure it out. I'll give you another hint before I reveal it, and that would be think of the video and think of what I've always keep telling you about this video, is that I believe it was a full collapse. The camera went back, grabbed 5 or 6 seconds, whatever amount of video we're observing, and then it restored that onto the hard drive. Now, when we look at the video, most people look at the video, they see what? Pause the video, pause this video, and rethink about what I just said. If you want to try to solve it before I give it up, just pause the video. All right, what is a hammer and nail? I'm going to go forward now. So what does a hammer and nail have in common? And then I'll go to the video last, the collapse, and see if you can catch on. I'm trying to do it to give you hints before, so you can beat me to it, if you will. So this will be, this is K, L, M. Let's verify that. K, L, M. Okay. This is very interesting. These are G's. These are G. Yeah. So these are G's, and you can see the shape of them, and they're signaled, they're identified. But this one is clearly like this. Clearly, not by mistake. It's on multiple of these drawings, these plans here. This is the one that goes up to the roof, floor 11. And then we transition to the penthouse, floor 12. But at floor 11, they do a transfer beam type setup. I believe it's something like this over to maybe it's there. And it's that one where we look in the sky view. If you look up there at that, where the air conditioners are, it comes through. Here's a walkway here, and we observe this. Top view, we see the beam like that, and then the one that goes across here. And then the walkway goes like this. And let's see if I can get this right, so I'll have to go further out over there, make that a beam up here, and then cut across for the hallway, penthouse. And there's the air conditioning units here, here, and here, and here. Let me show you. So we have this one here, I believe, is our plane. Here's the other column there. We're going to zoom in on it. I think the other one's back here. This goes here, and there's this beam set up like this. And then it has a column also. Let's go ahead and zoom in. Let's rotate around a bit. Zoom out. And we look like we're in line with the G's. Remember, this one goes like this, though. All right, so that looks like our G. And this should be our K, flower pot, plant box. So that's our K line. So K, L, M. Then you come back to the building to find it. This is just a block wall where the windows meet, etc. So this is K. Okay, and then right between there is the other column. Can't see it with this rendering. All right, so we'll go from there. So there's, and I'm going to show you a model of this also. You know, I'm doing a cardboard model for you. Right now, though, I want you to see the K, the G system. And now I want you to think about, as I show it on the first 2023, I do a release video. I don't know if this one will be before that or after. Depends on how I'm feeling. The feeling was, so here's the fracture I'll be discussing. And I believe after the deck collapsed, it rattled the building and vibrated through the building. And the roof collapsed first after the deck. You're like, but nobody's saying that. Nobody's saying the roof collapsed first. So everyone's saying you clearly must be dumb, because here's M, and we see M buckle. Approximately maybe over here by N also, right? So we see M buckle. Well, think about the hammer and the nail again. So this roof, I'm going to show with the cardboard, and I show reveal here. I don't know if I've already revealed it or not per the video part 2, or this will become part 2 and I'll move part 2 to part 3. I don't know yet. You'll know when you already just caught up to speed. So when this roof goes down, it hammers this structure. This slab hammers the structure. It folds maybe down to here. And that first initial impact that stresses this building, the load transfers to K, L, it's already on K, L, and M. M decides to be the one to, with the impact, with the load, shock loading of the structure. And I believe it maybe incorporates some of this on that flip, the building when it starts rotating down. I have a video on that I've already posted. I show this section below not buckling for some time in the video. And so it shows you the K and L. Huh. Yeah, that's L. Yeah, that's L. That's the fake one. All right, so that's just a planter box there. It's fake. It's not on that line. It's not K, column, or L. And I say K and L, I'm talking about the columns that are in here. And I just projected it out here to make it easy. Thank you for that. So so when we see this hammer and nail, we observe the impact becomes a hammer and nail. The structure K and L, they buckle. But somehow this impact stresses across and down M, and the load, transfer the load down M. M is where we're looking for to fail at the first floor level, basically inside 111 years. We need to see it fail there, the M. And that can fail in many, many capacities, if you will. Once M fails, the unsupported span now goes from here, so that's K, L, to N. If I got N right, N's the flower pot right here. The unsupported span, even though this is a column out here, but that's not doing the work. The work is, let's see, it's back here, M. So the unsupported span is here. So the great span is here. That's a full span. But M is no longer there. So these floors, or the front part of the floor of the structure, is no longer front part. The M is no longer supporting all the way down to the pier caps, pile caps. So the down to the pile caps. The load is not continuous. It's not a continuous path. And that's when we see in the video what appears to be a buckle, the building going down here also, around M. So everyone says, oh, it looks like M, it failed at M. But remember, you can stop the video right now, but I'll give you a hint again. It's a video we are looking at. That video, and I've said it numerous times, we're looking at a video that the collapse has already fully happened. The camera, I believe, has a motion, can recapture, 5 or 6 seconds beforehand what just took place. So it goes back, it captures it. And what we observe is that it appears M buckles and the roof is going down at the same time. And those things, when engineer-wise goes, well, it's got to be foundation there. So let's go with M. Approximately around M. This is where it's buckled first. And somehow we've got this roof collapsing. I believe that the rattling of the building, at this time, with my processing, that I believe the rattling of the building caused this failure up here. This is the rotation inwards, and we see the ductwork. This will be in part 2. Maybe this will be part 3 they're working on right now. And we see the rattling, rotation. You know what? I'm going to put this in a private room, and then I'll make it public also. So private people will get this first. So you private people, you're seeing this, but you're not seeing part 2 because I don't have a duplicate of part 2. I lost it. I deleted it. So it's only on YouTube. If YouTube deletes it, it's gone. So here's our rotation there. It's part 3. So then our rotation, and I'll show this with my cardboard demonstration on that. So this will be provable to you. This will be me trying to debunk myself, and you'll see that no, it's solid. So when we look at it, we're looking at a video again, and they went back 5-6 seconds, and what we observe, it just happens to be the timing of the buckling around M, what appears to be buckling of some type over here, jogging down of M collapsing. At the same time, we observe the roof going down. Well, just pretend like you can grab another, and instead of 5 or 6 seconds, maybe you can go back, if you could go back 8 seconds. You would see the roof go down, I believe, and then that hammer nail effect driving down on here, all three of them. Turns out that M just got up for the task for taking that shock load, that hammer nail effect. So that's when we see it, that it looks like M driving down, failing at the base, and the roof coming at the same time. Just imagine if you could grab more seconds, go back in time, you would see the roof go down first. Impact driving, M couldn't take the multiple impacts of the hammer nail effect, if you want to think of it like that. It buckles and fails. To prove that, I would need more data on M, but we see M is collapsing. Now, let me pause it and show you the video again, and now reimagine. So now I want you to, as you look at this video, I want you to reimagine now, going back a few more seconds, and you see the roof go down first, rotation, and the multiple impacts. But this time, you then introduce this video, and it looks like, oh, what we observe, oh, it's M. Well, when we do our math over there, it's M over to N. That's what's going. That buckled first, and then nobody's explaining the roof why it's doing that. Well, I think I'm explaining the roof, the actions. Let's look at it. So I think I can go back a little bit. And you know what? I think I can change the speed on this. And let's go again. So that's where we see M tearing down. But I'm okay. So I want you to think of the M. Are we making this up? Are we making up M being buckling? Or it's sort of like I did somebody today. They had a fake candle on the table. It was a light inside a candle box. I showed the guy next to me about my amygdala theory, and I was like, "Hey, look, put your finger inside the candle there. That thing." He said, "You see the candle?" He said, "Yes." So he just assume it's a candle with a flame. It's a light, though. It's not a candle. It flickers too. You know, the pulse they put on it. He said, "No, I'm not putting my finger in there." So I pick up the candle. I show it to him. He looks at it, and he says, and he already makes his mind, it's still a flame. And then I said, "Look again." He said, "Oh." I said, "Now put your finger in there." And he's like, and he didn't want to put his finger in there, even though he knew it was a light, because you've already made your mind that it's a flame. Be careful of our biases. Those are our biases. So I ask you, is M really the one here? Look, let's back this up. Are you actually seeing M buckle? M is to the right, right? M is right about here somewhere. Are we actually seeing M buckle before the roof drives it down with the hammer and nail effect? Is M really delayed? We just, excuse me, we just assume that it's a buckling down below. I don't have it. See it? If you look at the video, now you see that everything seems to be almost in place. We see some light move around, but if you watch this light here, it goes down to here and then jumps up there. Well, isn't that interesting? It's just maybe it's just a reflection. But it's not for a while before we get the teardrop going on. Let me try to see if I can do that again. There we go. So it brightens it up. But look at M. M looks like it's still about right. The floor is a little bit distorted. I don't know what we're looking at. Again, this is a processor you have to, like the camera sensor you have to think about also. I want you to look at these floors here. I'm doing that on purpose, exaggerating. I want you to see what appears, this little section like that. Let's do that again. Do you see the deviation, if you will? And you can see how, I mean, think about the sensor. It looks pretty far set back This one looks pretty far back. The one to the right looks like it's way forward than the one in the middle. We know they're in the same plane. That plane of the building is in the same plane, except with the exception of the porches sticking out in the kitchen. All right, let's do this again. I'm going to scrub it now. Oops. Oh, it won't let me scrub. Hold on, let's try this then. Okay, so that's quarter speed. And if you remove the lights, just don't think about these lights as anything. Don't try to read anything into the lights at this point. Don't read anything into the lights. Do you see this changing, this floor changing? Is it dropping down? Is it dropping down? Ask yourself that. Look. Observe. Not till about right about here. Now we can clearly see a deviation up top. So now we're seeing, but it's up top. And this is almost level still. And we're getting a facade, this going down, driving this facade, the front of the building, the L line, 9.1 line. Anyway, the face of the facade, the face of the building. We can see this K and L pretty much flat. I'm going to back it up again. I want you to look at it again. Now it's pulled onto the front. But it's pretty stable over there. Let's do it again. Let's back up. I want you to look at those columns. Observe these columns right here. Here. And I want you also to know that if we can go back in time right now, we would see that if you observe it at this point, but we don't see it buckling right now, it looks like the columns are in place. If you look at them, it looks like they're in place. Looks like we got lights on here and here. Looks like they're in place. So just go to the roof now and just back up in time. Roof is failing. Ultimately, it's going to pull down the other one is the other structure to the right more. Start driving this roof, the roofing to the right, and the facade, the front plane down also. And then we'll see a little slight buckle here eventually, but right here, but only in the concrete here. And as you remember, these sausage links, I call them, they're pretty engaged. They didn't buckle. We don't see a buckle in any of the materials we find in the ground. We see floor separation. Let's go. See, it's above. These guys are still parallel. They're still straight. So that's K, and that's L, I believe. It might be M. I mean, it really might be M. I might be off. K might be back here hiding out in the dust there a little bit. I think that's the two windows, so I'm going with the K. I'm willing to move, but that's K. The brickwork block in the middle, L, and M's back here. So these guys are firm. And now a hammer and nail effect. Here we go. And we got some tearing going on, a lot of debris falling. And eventually we get that roof deviation. And then still, a K is perfect. And then it looks like a little buckle between K and L of the block wall system. Right there, right where you may see it, right here. So this seems to be the roof, right? I said I'll get us into the building. Now look. Let's do it again. So now I want you to remove your bias about it has to start at the bottom. I want you to pretend like 10 seconds you can go back in time. You would see the roof where it is now. You'd observe right now, because luckily we have it, where at K, L, and M, the whole plane there looks unbuckled. So we can't say it started there if you're looking at it now and you've got collapsed the roof structure already and you have no indication of lower collapse yet besides the pull deck. So I'm saying it just rattled this guy up here, knocked the roof down, and that butterfly effect right there, based off that G one, and I'll show it to you, the G columns. I'll show it to you again, but this is what I'm stating. Let me let it play again, and I'll show you one thing before I terminate. You see, it's still there. Now there's the buckle, and that's what I see. Oh, that's how I'll put it together. So here's K, L, M. K, there's a planer box, L, and M. We see the video. We're into it a few seconds. The collapse has already started. I believe this G is probably what collapsed. That top part started the rotation down, and I can move it over to here a bit. But I like it. I like it in the middle there. Also, what I find interesting is that he really punched out details on this, architect and engineer. If you see here, this is still G. G is supposed to all be the same. I'll show it to you. He put 16 fives here. He put 17 fives there. He put 16 fives here, so these two are the same. 16 fives here, the same. On this one down, he put 18 fives. But these two in the middle, this is L and M, 16 fives. So these two, same. These are not the same. These are 18 fives. So he went up by 2 in this direction. In that direction, he went up by 2, and in the other direction, he went up by 1. And so, let me think of well, if I knew the spacing here between these two, I'd be able to tell you which way he chose. So, it went up by 1 this direction. This column, I don't see it changing. But our rattling, we could get the punching shear through. So this is the outer deck. Right, that's where it's connected. And you see what I just drew, right? You see how bad it looks. Let's do it again. So I'm going to do our connections. And in the middle, I'm going to put this one, hold on. And we'll change that. Let's do it again. I'll do it in this color. So now I want you to see that all our entire span there of that, the tributary areas are loading onto, the top deck, are loading onto column 1. This 1G. 1G. Now, this is significant, this wall here. Remember, the cantilever effect allows it, that I call it, it allows for a lot of bracing. And in fact, when it fails, we do see a lot of floor system left behind. Right about there. So, this is where it's fractured from here. It would be, so let's look at it as a cutaway. So, here's a building. I'm going to do that little cantilever like that. So this one is this. And then I'm going to put a deck back across it. Fully over to here. Let's say, when I say over to here, I mean here. Right here. And now I'm going to butterfly this like that. I'm going to take some exaggeration here. Move that over a bit. When the jet rattles, put it right about G. So let's call this G. And we get punching shear around this one right here, and now we get the progressive collapse. This engineer thought that this was loaded differently than here and here. Even though this ledger is pretty ledger there, his design tells you, his reinforcement tells you that's what he thought. He made a bigger critical shear zone there because of its loading. It's loading. He only added 2 extra 18s, 1 extra 17. And then these are 12 fours. Oh, look, 13 fours. These are all the same across the front. Oh, I'm sorry, let's just stop there then. 13 fours, 13 4 rebar, 13 fours. Outside the wall there, inside the wall there, you use the hooks. And I think he would have, for a gate, for engagement. Sorry, I'm looking at his other note there. I'm going to zoom my eyes in and out for a second there. Okay, so this is where I believe we get some punching shear going on, but it develops itself like that in the butterfly effect. And I'll show that because of the ductwork. That's part 2. And then I'll do the model, part 4, I think. So it looks like here, let me zoom this in for you so you can see the columns first. So I want to show you the column here, here. These are columns. This is the wall ledger system, and so I'm going to come back here. This is where that fracture exists. It stayed. We do that. Oops. So let's take a look at that again. I'm going to draw you in like this. I'm going to come across. I think it's over to here. Go like this, and I'm going to come back across. Porch is a cantilever. I'm going to put a column here. This is our punching shear area, I believe. And this is a piece of shelving that stayed, some concrete. And so this is column, and legend walls where I care about here. I'm observant of that. Alright, so this is a punching shear location. Punching shear. And location of first failure, main building failure, I think. First, this building failure, this tower. First area. Okay, so I'll do a plus or minus on that of about 3%. All right, what do you guys think? Hopefully that helps you see it. Excuse me, a little better. So I have to add a little bit to this, dude, for my editing reasons. So I'm just saying hello, Merry Christmas, whatever. Just adding a few seconds here. It's for something I got to